Welcome everyone to another episode on this channel. If you've been trying to keep up with the ever-evolving world of artificial intelligence, you've probably noticed researchers love their acronyms. Today, we'll be diving into RAG, or Retrieval Augmented Generation. Buckle up because this is going to be an exciting ride. First off, what is RAG and why is it so significant? Retrieval Augmented Generation is essentially a method that aids AI, like chatbots, in answering questions about fresh information. Think of it as giving chatbots the ability to look up answers. This approach can address the problem of hallucinations or wrong answers chatbots sometimes provide. So, how does this impact developers in the AI field? Developers usually have three choices when working with AI. Build a model from scratch, fine-tune an existing model, or use RAG. Building from scratch is costly. Fine-tuning can make a model forget its original training. This is where RAG, with its blend of traditional search and model capabilities, stands out. The mechanics behind RAG. Let's get technical for a moment. How does RAG work with large language models, or LLMs? With RAG, instead of training a model with new data, you give it access to a vector database. This database has the new information the model can refer to. It's like adding a reference book to the AI's library. For instance, OpenAI's GPT-4 might not know about a company's specific HR policies, but if it has a vector database with those policies, it can provide accurate answers. How do businesses benefit from using RAG? RAG allows businesses to optimize costs, maintain data relevance, and leverage the reasoning capabilities of LLMs. Companies can now provide their models with the latest data without the extra costs associated with training them from scratch or fine-tuning. This makes integrating LLMs into businesses more streamlined. So how does RAG work on LLMs? Implementing RAG involves several steps. First, the large data is chunked. Then, these chunks are converted into a searchable format and stored in an accessible location. LLMs can then use this stored data to generate informed responses. Platforms like Azure Machine Learning have even streamlined this process, offering support for RAG-based scenarios, data management, and integration. What are some real-world examples to clarify how RAG works? Let's say we have a vast database of scientific articles, and someone asks, what are the latest advancements in oncology? Without RAG, an LLM might provide an outdated overview. With RAG, it'll first fetch the latest articles on the subject from the database and then use this fresh data to provide a much more updated and detailed response. Before we wrap up, why should someone consider implementing RAG? Well, RAG offers scalability, flexibility, and quality. By separating the retrieval and generation processes, you can leverage vast amounts of external data efficiently. Plus, the retriever can be updated without affecting the generator. And, in many tasks, RAG has shown improved performance over traditional models. RAG seems to be bridging the gap between what AI knows and what it can know. Stay tuned for more insights on the latest in tech on our next episode. Until then, keep innovating.